We can stop HIV, Iowa.
One key step? Getting tested for HIV.
An estimated 14% of people in Iowa living with HIV don't know their status. The CDC recommends everyone get tested for HIV at least once in their lifetime, or more often when needed.
So testing is important.
Yes! Testing is the only way to know your status. It's the first step in getting additional HIV prevention services or HIV care.
Find out more at stophiviowa.org.
This is SpaceTime, Series 26, Episode 27, for broadcast on the 3rd of March 2023. Coming up on SpaceTime, the asteroid that almost swallowed a spacecraft, 59 new exoplanets discovered in our stellar neighborhood, and SpaceX says it's still hoping to launch what will be the world's biggest and most powerful rocket ever, the Starship, sometime this month. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Well, it sounds like something out of a 1950 sci-fi movie, but it now seems like the asteroid Bennu almost swallowed NASA's OSIRIS-REx spacecraft during its sample collection maneuver. 10-1955 Bennu is a carbonaceous Apollo group rubble pile near-Earth asteroid. That means its orbit intersects and crosses with Earth's orbit around the Sun. The 492-metre-wide space rock currently has one of the highest known chances of actually hitting the Earth, with a 1 in 2,700 chance of impacting Earth sometime between 2175 and 2199. If it were to hit the Earth, the resulting impact would be the equivalent of a 1,200 megaton thermonuclear device. On average, an asteroid the size of Bennu crashes into Earth roughly once every 130,000 years or so. But Bennu's orbit is intrinsically dynamically unstable. Dynamical studies predict 8 potential Earth impacts by Bennu between 2169 and 2199. Bennu will pass just 750,000 kilometres above the Earth on the 23rd of September 2060. That's just 37.5 years from now. Now, that close approach will affect its next close encounter on the 25th of September 2135. That's expected to be around 300,000 kilometres above the Earth's surface, although it could be as close as 100,000 kilometres. Now, there's no chance of an Earth impact in 2135, but depending on how the asteroid's affected by that close encounter with the Earth, future encounters with Earth start to get really interesting. See, the asteroid could pass through a 55-kilometre-wide gravitational keyhole, which could create an impact scenario during a future encounter. Because of these issues, NASA sent the OSIRIS-REx spacecraft out to study Bennu and bring back a sample for detailed examination. Launched from Cape Canaveral in September 2016, the probe arrived at Bennu in October 2018. OSIRIS-REx spent 3 years orbiting the asteroid, mapping its surface, studying its composition, examining its geology, its chemistry and mineralogy, and trying to work out its evolution. One of the key mission objectives involved understanding non-gravitational influences on the asteroid, things like the Yarkovsky effect, in which sunlight heats up the surface of an asteroid and that stored heat is then radiated back into space, providing a small amount of thrust as the asteroid rotates. Bennu is a rubble pile asteroid, a collection of rocks, boulders and dust loosely held together by its own collective gravity. Knowing Bennu's physical properties will be crucial for scientists trying to determine the likelihood of this mountain-sized space rock actually slamming into the Earth. In July 2020, OSIRIS-REx flew down to the asteroid's boulder-strewn surface and briefly touched down to collect samples of surface regolith. The spacecraft then left Bennu bound for Earth in March 2021. It'll swoop past the Earth in September this year, jettisoning its sample return capsule, which will parachute down into the Utah desert. The sample collection involved the spacecraft's 35-metre robotic arm touching the surface of the asteroid with its sample collector, then releasing a gentle puff of inert nitrogen gas to blow some dust and pebbles into a collection chamber. The spacecraft then slowly lifted off the asteroid with the sample intact and returned to orbit. More recently, scientists have had a chance to carefully examine just how that operation went, and they were shocked by what they found. It seems rather than a gentle kiss, OSIRIS-REx punched right through the surface of the asteroid. The arm and collector didn't stop when it touched the surface, but continued down another half-metre or so before the spacecraft began lifting up again through the clouds of debris and dust which were blasted out, in the process leaving behind a massive elliptical crater some 9 metres long. If the spacecraft hadn't been programmed to lift itself back into orbit a few seconds after landing, the half-kilometre asteroid would have swallowed it whole. It turns out the asteroid's so loosely bound together that even the brief jet of gas that was meant to delicately blow surface material into the collection hamper instead blasted out some 6 tons of rock and debris, literally showering the spacecraft. Mission managers at the time simply saw a huge wall of debris radiating out from the sample site. Fortunately, the instruments all kept working. The team were able to get a direct spectrum of the particles that landed on the spectrometer optics, which confirmed other measurements showing that Bennu includes carbonaceous materials like those found in other primitive asteroids, but with a history of interacting with water. By the way, all that debris left the collector overflowing, with some huge particles preventing the cover from closing until some of the excess was carefully shaken out. 8 days after collecting the sample, mission managers were finally able to close the collector hatch with an estimated 250 grams of material crammed inside the sample hopper. This report from NASA TV.
One of Earth's closest neighbors is a dark, jumbled mass of rocks and boulders known as Asteroid Bennu. Bennu is ancient, a rugged survivor of the solar system's chaotic past that may hold clues to the origins of life. In October 2020, a NASA spacecraft called OSIRIS-REx touched down on Bennu and collected a sample for return to Earth. Scientists had expected that this touch-and-go event, or TAG, would have little impact on the asteroid. After a slow descent, the sampler head would briefly make contact, inject a puff of gas, and capture a handful of material. Perhaps it would also leave a small divot at the sample site, a subtle footprint in the soil, or so it was thought. When images of the TAG event beamed back to Earth, they were far more dramatic than anticipated. Despite its slow touchdown, OSIRIS-REx had punched through the surface and set off an explosion of loose material. Tons of rocks and pebbles were ejected, radiating outward in a wall of debris. The pictures were stunning, but why did Bennu's surface behave so unexpectedly? The answer involves cohesion, an attractive force that can bind molecules together. Cohesion gives water its surface tension and keeps droplets together even in a microgravity environment like the International Space Station. Granular materials like wheat flour, cocoa, and dust can also exhibit cohesion, which pulls individual grains into clumps. On Bennu, scientists had expected cohesion to act like a bit of glue between the rocks, making its loose surface more solid. But the TAG event showed that Bennu's uppermost layers are nearly cohesionless, deforming under stress like a fluid. A good analogy is a ball pit. Although the plastic balls are solid, they easily slide past one another and past boisterous children, behaving in mass like a fluid. Thanks to OSIRIS-REx, we now know that Bennu's surface is not held together by cohesion, but by gravity, or microgravity, with a minute tug less than 100,000th the pull of Earth. On the Moon, gravity is 16% as strong as it is on Earth, and more than 16,000 times stronger than it is on Bennu. As a result, loose material in the lunar subsurface is packed together more tightly, making the Moon's surface relatively firm. If a 50-kilogram mass of solid iron were to hit the Moon at the same speed as the TAG event, it would sink into the ground by only half a centimeter. Repeating this experiment at Bennu would yield a dramatically different result. Though the mass would strike with the same force, it would plunge 17 centimeters before stopping, over 30 times deeper than at the Moon. Bennu has consistently defied scientists' expectations, as each new finding reveals another facet of this small but surprising world. Using data from OSIRIS-REx, we now have the ability to look back and accurately recreate 30 seconds on asteroid Bennu. On October 20th, 2020, OSIRIS-REx made its final descent to a sample site called Nightingale. With its TAG-SAM arm outstretched, it approached the surface at 10 centimeters per second, the walking pace of an insect. 1 second after contact, it released a canister of pressurized nitrogen, detonating an explosion of particles and driving material into the TAG-SAM head for sample collection. 6 seconds after contact, while it was still sinking into Bennu, OSIRIS-REx fired its thrusters to begin the back-away maneuver. The engine burn lasted for 24 seconds, continuously pushing against the spacecraft and rapidly slowing its descent. Flying debris from the thrusters and the gas release pelted the science instruments, clogging them with dust. 9 seconds after contact, when OSIRIS-REx had sunk nearly half a meter into Bennu, it reversed course and began to rise. At 16 seconds, the TAG-SAM head re-emerged from the subsurface as the spacecraft continued to accelerate. 30 seconds after contact, OSIRIS-REx shut off its thrusters and drifted away with its sample of Bennu. Almost 6 months later, on April 7, 2021, the spacecraft returned for one last flyover to observe its footprint. At the point of impact was a new crater, averaging 8 meters across and reaching 68 centimeters in depth. Thruster marks overlapped with this TAG crater in an X pattern, increasing its volume by as much as 40%. A ridge of ejected material that had been kicked up during sample collection and then fallen back to the surface circled the crater like a campfire ring. With a puff of gas and an engine burn, OSIRIS-REx had displaced 12 cubic meters of granular material, 6 tons of loose rock that may have been packed together as lightly as a bowl of popcorn. After a final departure maneuver in May 2021, OSIRIS-REx began a 2-year journey back to Earth. Stowed on board were about 250 grams of asteroid Bennu, a bounty of scientific treasure destined for future discoveries.
Meanwhile, Jonathan Alley, the editor of Australian Sky and Telescope magazine, says 2 studies reported in the journal Science and Science Advances details the spectacular events and looks at the lessons it provides for scientists wanting to study rubble pile asteroids.
The idea was that it would just very carefully, very slowly sidle up to this asteroid and stick out a robot arm and touch the surface of the asteroid with a robot arm and grab some samples of the sort of rocky, dusty stuff that was no doubt on the surface, scoop them up, stick them in a canister and bring them back to Earth. And that's exactly what it's done. It's done the sample collection now, and it will be coming back to Earth, parachute down through the atmosphere and be able to get our hands on these samples of this asteroid. But so what happened when the spacecraft sidled up and stuck out its robot arm just down touched the surface? It had a nitrogen gas system on the end of the arm, which was designed to let out a puff of gas, which would stir up some of the material from the surface and blow it into this collection scoop, right? All good stuff. So what they weren't really expecting is that the surface of this asteroid would be a loose rubble pile rather than fairly solid rock with just a loose, thin covering of dusty, rocky stuff. So long been pondered whether some asteroids, or maybe a majority of asteroids, or all of them, are actual big solid lumps of rock, or are they loose rubble piles just barely held together by their very tiny gravity. So it turns out that the surface of Bennu is a loose rubble pile. And so when this nitrogen gas blast went out, it gouged a crater 9 meters long and ejected about 6,000 kilograms of dust and rock out into space. And the spacecraft, instead of sort of hitting the surface and stopping, it went in. The robot arm went in by about half a meter into the surface of this thing. And so if it had kept going, who knows what would have happened, whether it would have got stuck there or half got buried or something. But fortunately, it didn't. It was able to back out.
It's like a giant dust bunny.
It's like a giant dust bunny, or quicksand, like sticking a hand in quicksand or something. So they were sort of lucky there. But look, this is good because they've learned something about this asteroid, and this is the whole point of doing this about these asteroids.
We won't need Bruce Willis after all.
I think we never did, to be honest. But what was the name of that movie he was in?
Armageddon. Yeah, Armageddon. That movie.
So what if I can't remember Armageddon? It's not the end of the world.
Boom, boom. We're in a fascinating time when it comes to asteroid studies now, aren't we? It's not just smashing into an asteroid with the DART mission. We've had a couple of Japanese missions now, the Hayabusa missions, study asteroids close up and personal, and now OSIRIS-REx.
Yeah, look, and it's really remarkable that they're doing this. I mean, they're just the most brilliant people to be able to devise these missions and get them out there, make them work, and bring these samples back home, because asteroids are in one sense, thought to be sort of the builder's rubble of the solar system, the sort of leftover bits from when everything formed in our solar system. So by studying them, you're studying some of the most ancient, unchanged materials in the solar system. So that's of great interest for scientists to work on their ideas of the formation of the solar system and how everything has evolved. But the other thing, of course, is that if we ever do need Bruce Willis, if we've got one of these things coming towards us, then we really want to know, is it one big solid rock? And if we go out and give it a nudge, it's just going to move away? Or is it a loose rubble pile? And if we go out and give it a nudge, is it just going to break up into lots of pieces? And all those pieces then are coming towards us and we can't deal with it. So it really is important to know your enemy in this sense, or your potential enemy, which is why they're trying these different asteroids out there and trying to learn as much about them as possible. So it turns out that probably a lot of asteroids are big rubble piles, and if we ever do spot one coming towards us, hopefully we've got enough time, hopefully decades, to go out and do a reconnaissance mission, see what sort of asteroid it is, and whether we can afford to hit it with something and knock it off course, or whether we have to be a bit more judicious in what we do, try some other method. So it's both scientifically interesting, and it could have a practical application one day if we ever spot one coming towards us.
Yeah, and it's exactly the same with comets we're finding now too. The European Space Agency's Rosetta mission showed that not all comets are dirty snowballs. Some of them are really solid chunks of rock.
They are. Look, you go back to the 1980s when Comet Halley came around, and the Giotto mission, the European Space Agency Giotto mission, gave us our very first close-up look at a comet, Comet Halley, the famous Comet Halley. And what they were not expecting was that it was basically pitch black. It wasn't this bright, shiny thing made of ice at all. It was this tar-covered black thing, quite large. And so we quickly went from the old idea of comets being dirty snowballs to comets actually being snowy dirt balls, which is probably more like it. They're probably more substantial and then just covered with ices or mixed in with ices. And there's also this crossover between comets and asteroids. It used to be comets made of ice, asteroids made of rock. And now we know that there are sort of ones in the middle, and sometimes they discover something, they think it's an asteroid, and then sometime later, months or years later, all of a sudden it's got a tail. Oh, that was a comet after all. And vice versa. So it's interesting. We're learning more and more and more about what's out there.
Well, Phaeton's a good example of that, isn't it?
Beg your pardon?
Phaeton, the rock comet Phaeton.
The rock comet. Is that by Andrew Lloyd Webber?
The Comet 3200 Phaeton is where the Geminids are coming from, the Geminids meteor shower.
Oh, look, Hollywood will be knocking down my door any day now.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine. And this is SpaceTime. Still to come, 59 new exoplanets discovered in our stellar neighbourhood, and SpaceX says it's still hoping to launch what will be the world's biggest and most powerful rocket ever, the Starship, sometime this month. All that and more still to come on SpaceTime. A survey of nearby stars has discovered no less than 59 previously unknown exoplanets, around a dozen of which are in their host stars' habitable zones. The findings, reported in the journal Astronomy and Astrophysics, include some 20,000 observations taken between 2016 and 2020 of some 362 nearby red dwarf stars. Astronomers made their observations using spectroscopic readings taken by the Carmenes Optical and Near-Infrared Spectrograph at the Calle Alto Observatory in Spain. Spectrographs work by breaking down light into its constituent components, providing details about where the light came from and what it passed through or reflected off. Astronomers can use this data to determine things like chemical composition, temperature, distance, and even how fast something is moving towards or away from you. This spectrograph's high resolution can detect slight wobbles in a star's position caused by the minute gravitational pull of an orbiting planet. The duration of the wobble tells astronomers how far away the planet is from the star, while that and the degree of the wobble provides details about the mass of the planet. Of the 59 exoplanets detected, 12 were in their star's Goldilocks zone, the habitable region around a star where temperatures are not too hot and not too cold but just right for liquid water, essential for life as we know it, to pool on a planet's surface under the right atmospheric conditions. This study's authors have already been instrumental in the discovery of several other rocky planets. Recently, they reported on Wolf 1069b, one of the most promising exoplanets that may be able to sustain habitable conditions. Since it came into operation, Kameni's has reanalyzed 17 known planets as well as the 59 new discoveries. Importantly, it's now observed nearly half of all the known nearby red dwarf stars visible in the Northern Hemisphere. Astronomers focus on spectral type M red dwarf stars because orbiting planets are easier to detect around these stars. They're small and not so hot that their glare outshines any nearby planets. They're also the most common type of star in the known universe, making up over 3/4 of all stars in our galaxy. In fact, the nearest star to the Earth other than the Sun, Proxima Centauri, located some 4.23 light-years away, is a red dwarf. And because red dwarfs burn through their fuel supplies relatively slowly compared to more massive stars like our Sun, they tend to live a very, very long time, possibly trillions of years, compared to our Sun, which will live for around 12 billion years. In fact, as far as we know, no red dwarf star has ever died. That means that life, if it exists anywhere else in the universe, would have lots and lots of time to get started and established on any planet orbiting in the habitable zone of a red dwarf star. However, red dwarfs are also flare stars. They erupt with powerful stellar flares that can blow away the atmosphere of any nearby orbiting planets and irradiate their surface. But some astronomers believe this only happens early in the star's history, and eventually they become far more settled and sedate, thereby allowing life to get a foothold. This is SpaceTime. Still to come, SpaceX says they're still hoping to launch Starship, the world's biggest and most powerful rocket, sometime this month. And later in the science report, intelligence reports suggest Iran now has enough enriched uranium to produce at least 4 nuclear bombs. All that and more still to come on SpaceTime. SpaceX says they're still hoping to undertake the maiden orbital test flight of what will be the world's biggest and most powerful rocket sometime this month. Starship is the culmination of SpaceX boss Elon Musk's dream to develop a fully reusable interplanetary colonial transport spacecraft capable of carrying people or 150 tons of cargo to orbit and 100 tons on more distant missions to the Moon, Mars, and interplanetary journeys across the solar system. Last month, SpaceX successfully ignited 31 of its Super Heavy boosters' 33 Raptor 2 main engines during a static test fire. However, the burn only reached half throttle and it only lasted for 6 seconds. One Raptor 2 was shut down by technicians before ignition and another turned itself off. Musk says 31 of the Raptor 2 engines is more than enough to reach orbit. When it does fly, SpaceX are planning on using Starship prototype ship 24 and Super Heavy booster 7. The massive 120-metre-tall, gleaming stainless steel Starship and Super Heavy booster stack will launch from the Starbase facility at Boca Chica on the Texas Gulf Coast. If all goes to plan, the booster and spacecraft will separate about 170 seconds into the flight. The booster will then splash down about 32 kilometres offshore in the Gulf of Mexico, while Starship continues to orbit, circling the Earth once before executing a deceleration burn and re-entering the atmosphere. It'll then perform a propulsive landing on the Pacific Ocean about 100 kilometres northwest of Hawaii. Once it's fully operational, the Super Heavy boosters will land on the same launch pads from which they take off. And the Starship's upper stage, which is equipped with its own retractable landing gear, will undertake rocket-assisted vertical landings just as have been perfected by SpaceX's current Falcon 9s. Once their flight proven, SpaceX plans on using the Starship Super Heavy launch system to replace the company's existing Falcon 9 and Falcon Heavy launch systems and its Dragon capsules. As well as the Starship upper stage, SpaceX is also building an HLS or Human Landing System version for NASA for missions to the Moon. The HLS will be used to rendezvous with the Artemis 3 Orion spacecraft in lunar orbit, where 2 of the 4 astronauts aboard Orion will transfer to the lander, which will then take them down to the lunar surface. And after 2 weeks on the surface, the HLS will take the crew back up to the Orion capsule in orbit, where they'll transfer back to the Orion for the journey back to Earth. Later, the HLS will dock with the Lunar Gateway space station once it's completed and in lunar orbit, and it will be used to shuttle crew, cargo and supplies between the space station and the lunar surface. Refueling tanker versions and satellite or heavy lift cargo versions of Starship are also being built. However, SpaceX have announced that they've abandoned their plans to launch future Starships off converted floating oil rig platforms. SpaceX bought 2 former deepwater drilling rigs in 2020 for $7 million, which were to be converted into floating launch platforms named after the 2 Martian moons, Phobos and Deimos. However, both oil rigs have now been sold on. Meanwhile, 2 weeks ago, SpaceX launched another 51 Starlink broadband internet satellites into orbit from Space Launch Complex 4E at the Vandenberg Space Force Base in California using their Falcon 9 rocket. Following MECO and stage separation, the first stage booster returned to Earth, successfully landing aboard the drone ship Of Course I Still Love You, which had been pre-positioned downrange in the North Pacific Ocean. That landing was the 172nd overall landing for an orbital class booster by SpaceX, while the launch was also the 210th Starlink mission and the 11th so far this year. And just a few hours after that mission, SpaceX launched another Falcon 9 rocket, this time from the other side of the country off Space Launch Complex 40 at the Cape Canaveral Space Force Base in Florida. This mission carried the Inmarsat 6F2 telecommunications satellite into geostationary orbit. The 5,500-kilogram dual-band satellite is based on the Airbus Eurostar E3000 platform and equipped with a hybrid 9-meter aperture L-band antenna and 6 multi-beam Ka-band transponders. Following stage separation, the booster returned to Earth, landing safely on the drone ship Just Read the Instructions, which had been pre-positioned 665 kilometers downrange in the North Atlantic Ocean. Like it or not, they sure know how to put on a show. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. New research led by Australia's National Science Agency, the CSIRO, shows that future increases in the strength of El Niño events could accelerate the irreversible melting of ice shelves and ice sheets in Antarctica. The findings, reported in the journal Nature Climate Change, uses new climate models to show how an increase in the variability of the El Niño Southern Oscillation, or ENSO, leads to reduced warming near the surface, but accelerated warming in deeper ocean waters. ENSO is a key driver of climate variability, as both its warm phase El Niño and its colder phase La Niña influence weather conditions around the world, including Australia. Scientists warn that climate change is expected to increase the magnitude of ENSO, making both El Niño and La Niña events stronger. The new research, based on 31 climate models, shows that stronger El Niños would reduce warming near the surface of the shelves, but accelerate the warming of deeper waters in the Antarctic shelf, making the ice shelves and ice sheets melt faster. Chinese researchers have developed a bionic finger that's modelled after your own very sensitive fingers. It can even fill out a 3-dimensional map of what lies underneath your skin. As opposed to previous artificial sensors, which could only really tell the difference between external shapes and surface textures, the Chinese team say their finger gets its information by moving across an object and applying a constant stream of minute pokes. Each poke sends back information regarding the relative stiffness or softness of the object. That allows researchers to convert the data into a 3-dimensional map of what's lying underneath a squishy top layer. They say their device has the potential to be used to detect faults in electronics without breaking through its protective layer. You can read the study in full in the journal Cell Reports Physical Science. The United Nations nuclear watchdog is holding crisis talks following reports that Iran has again stepped up its nuclear enrichment program. Bloomberg News is reporting that International Atomic Energy Agency inspectors in the Islamic Republic have discovered uranium enriched to 84% purity. The claims come as outgoing Israeli military chief of staff Lieutenant General Avi Kochavi confirmed reports that Tehran now has enough enriched uranium to build 4 crude nuclear weapons. Intelligence sources suggest Iran is at breakout point now and could deploy its first nuke within 3 months. However, other sources suggest the Islamic Republic would still need another 6 months to 2 years in order to perfect its trigger system, determine how to minimize the weapon for use on a nuclear missile warhead, and develop the missile re-entry system. This is where Tehran's so-called space program comes in. The news is the latest in a growing list of breaches of Tehran's 2015 Vienna Nuclear Non-Proliferation Accords. Tensions began to escalate last year following Iran's decision to turn off and remove 27 International Atomic Energy Agency surveillance cameras designed to monitor Tehran's rapidly advancing nuclear program. The UN nuclear watchdog says the Islamic Republic began using advanced centrifuges to enrich uranium in September 2019. It now has an enriched uranium stockpile some 18 times above the 2015 Vienna agreements. It's the latest in a growing list of broken agreements by Tehran, which includes refusing access to International Atomic Energy Agency weapons inspectors or disclosing the location of key nuclear weapons components in its possession. In February 2021, the UN nuclear watchdog found Iran had started producing uranium metal. That's a material which is only used in nuclear weapons. It has no other purpose. Then in April 2021, both the German and Swedish intelligence agencies warned of growing efforts by Tehran to obtain nuclear weapons technology. Meanwhile, an International Atomic Energy report in May 2022 warned there were still serious questions about traces of enriched uranium found at 3 sites named as Maravan, Varamin, and Taguzabad, which Iran had failed to declare as having hosted nuclear activities. The oil-rich nation continues to insist its nuclear program is for peaceful power generation only. Well, it looks like researchers have finally solved the mystery of the famous Loch Ness Monster. And the answer could be as simple as a unique type of wave generated by boats in long, narrow and deep lakes like Loch Ness. Called a Kelvin wake, it's created by the wake of a boat with screw propellers interfering with the boat's bow wave after it's been reflected off the steep sides of the shoreline and then back out into the middle of the loch. Tim Mendham from Australian Skeptics says when the angles are right and the conditions are calm, it exactly matches many of the sightings of Nessie, and he should know. He's been searching for Nessie for years.
Yes, I have been up to Loch Ness a number of times. It's a nice place to go in its own right, but obviously it's handy to try and see if you can spot the Loch Ness Monster, or Nessie. And over the years, really since the early 30s when a lot of this Nessie hysteria started, there have been suggestions as to what are these shapes in the water. There's definitely shapes in the water, and a lot of people are saying they look like humps, and people are suggesting eels or suggesting a line of otters at the same time doing a bit of water ballet or something, synchronized swimming, or it might actually
ridiculous.
it might actually be a monster, of course. And there's all sorts of suggestions, but this recent one is a theory that suggests that when you get a long, narrow lake, which is what Loch Ness is, that the wakes from boats rebound. Now, a wake from a boat, you get the line of the wake behind the propeller, say, so it's from the stern going straight out. But from the bow, you get the bow waves, which go out at a certain angle, as things they want to do in physics, and they spread out. And when in a narrow lake, they can actually bounce off the sides of the lake and come back in again. And when these two waves, the one going out and the one coming back in again, meet, you actually create a very weird wave effect, and some instances a standing wave that seems to be staying still. But this is only on very still days, where the water is very flat, no storms, no wind, whatever, and it forms this amazing sort of effect of what is basically ripples, but they stay there. Or they then move quickly away as they disperse, or they either diffract or refract or whatever, that these two
It's an interference
waves,
pattern.
Yeah, interference pattern, that's right, between two waveforms, one going out, one going in. And these things can last for half an hour in the water, these effects. So you might have a boat going up the middle of the loch, and then it's out of sight, half an hour gone, it's disappeared, but the wave still exists, especially if they're going out and coming in. And what you see from these wave patterns is very similar, well, the same, as a lot of photographs that people have put up for the Loch Ness Monster. It's called a Kelvin wake, actually, is how it's referred to. And this effect is quite stunning, and it complies, it actually matches a lot of the form, the shape, as well as the action of what is supposedly the Loch Ness Monster rising and sinking into the water. So it's all these explanations looking for alternative animals that might be in the water. This comes down to a very simple physics effect, which is perhaps not that well known and often misinterpreted, because the object, the boat that caused the original wake, might have well disappeared. I won't say over the horizon, the loch's not that long, but it's gone off in the distance. And so people say, oh, it couldn't have been the boat because that's up there. But it actually was the boat. And there were a number of boats that were regularly travelling up and down the loch over a period of time, initially for transporting before there was a road, I think even, but more recently, like at the last end of the 20th century, as a tourist boat. Because they take people up and down the loch, which is very pretty, very much worthwhile going, I'd recommend it, and therefore creating these Kelvin wave effects of the wake, going out, coming back in, causing an interference pattern, a standing wave, which looks very much like you would assume a Loch Ness monster would look. So this is actually quite a fascinating explanation, and this particular article that I was looking at explaining it shows examples of these waves and refers back to anecdotal evidence, the witness account of past Loch Ness monster sightings, and shows how they fit in perfectly with this wave effect. It's quite a fascinating suggestion, almost a little bit mundane, but it's a weird effect of physics and water, but only on clear days, only on calm days. You're not going to see it in choppy water, and you don't tend to see Loch Ness monster sightings on choppy water either. You really only tend to see them on these very calm days where the water in the loch is mirror surface, which is why the Loch Ness was actually used for water speed record settings. You know, they had speedboats running along Loch Ness, and so therefore it does get very, very still, and they move and they look like a monster should move and look. So it's quite a fascinating suggestion.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.